Hi, my name is Curtis Thorne, and I work with the X team here at Oracle. And today I will present OKV on Exadata Database Service on Cloud to Customer using REST. I will walk through a few slides explaining the migration process of TDE wallets to OKV, and at the end of the presentation, we'll execute a demo to go through the migration process. In this presentation, we will list the software versions that are required for the OKV migration. For OKV onboarding, we will walk through how to create wallets, how to create and manage endpoints, how to download and install the endpoint client software, and we will show an example of automating this OKV onboarding process. Also, we'll do a quick walkthrough of the required steps for the database and ExaDB Cloud to Customer changes, and we will also list the MOS node used for the REST OKV migration, which is the MOS node we will use to execute the demo. Required software versions. For the cloud tooling or DBaaS tools, DBaaS 21.3.1.1 and up is required for the OKV migration. The update of the cloud tooling can be executed on the KVM guest by using the tooling itself. The DBCS agent needs to be 21.3.1.1 and up as well. For updates to the DBCS agent, however, customers will have to work with ops to update if the proper version has not been installed. To find the versions for DBaaS and DBCS agent, run the following RPM query listed on the slide. For 19C databases, 19.6 and up is required for OKV migrations. For Oracle Key Vault, versions 21.1 with patch 332.72214 and up is required. The presentation will show the necessary OKV_home directory tree needed for the OKV migration. Also, we'll show an example of downloading the RESTful service utility using curl. The RESTful service utility is used to execute the REST calls to the OKV server. So once the RESTful service utility is downloaded, we must update the OKV wrapper script. The OKV wrapper script is a bash script that sets a few environmental variables and calls the OKV REST CLI.jar file. Also, we need to update the OKV REST CLI.ini config file, which is the config file where we specify the OKV server IP, OKV username and password if we choose to use those, the REST user, client wallet, profiles, etc. The OKV_home is the environment variable that points to the location of the OKV endpoint client software. Please be aware that the endpoint client software contains certs that are unique with each endpoint, which is why the OKV_home directory tree needs to be created on all nodes hosting the endpoints. The OKV_home has been referred to wallet_root in some documentation, so please be aware of that. However, to remain consistent with autonomous database, we standardize the OKV_home directory tree to use the OKV_home subdirectory. As for the directory tree, the OKV_home/OKV holds the bits, configs, logs, libraries, etc. Basically, the OKV endpoint client software. The OKV_home/TDE holds the auto login wallet for the wallets uploaded to OKV. The OKV_home/TDE_seps holds external key stores that help hide clear text passwords from the OS. In this slide, DCLI is used to create the OKV_home directory tree for each node where the endpoints are intended to reside. Also listed is an example of the curl download of the RESTful service utility. So please be aware that in this slide, the OKV RESTful service utility is stored in a directory specifically created to house the bits and configs of the RESTful service utility. OKV wrapper script. The OKV wrapper script is used to run the REST calls to the OKV server. So we set a few environmental variables. We set the OKV REST CLI config that points to the OKV REST CLI.ini config file. The OKV_REST environment variable is added to specify the full path to the directory of the OKV REST bits. And also we add the current Java home environment variable. This slide shows the update to the OKV REST CLI.ini config file. Since we intend on creating a client wallet for our REST user, we initially only need to set the IP of the OKV server. If the OKV server is not specified on the command line, then the server IP is required in the config file. Once the client wallet is created, we then add the subdirectory of where the client wallet resides within the OKV REST CLI.ini config file. The reasoning behind the client wallet usage is to hide the password from the OS for easier and more secure REST calls to the OKV server. And here's an example of how to create a client wallet for the REST user that will make the REST calls to the OKV server. We use the RESTful service utility, to create the client wallet by specifying the following. Client-wallet specifies the directory where you want the wallet to be stored. And in this example, the OKV rest/w subdirectory will store the client wallet. Wallet-user indicates the intended user that will make the REST calls to the OKV server. When we execute, the command returns a prompt to enter the password for the REST user. Once the correct password is entered, the client wallet is then created. As a side note, it's best practice to create a low-level privileged OKV user to perform the OKV REST calls. The only privilege that this user would need is the create endpoint privilege. Also, it's highly recommended to not use an OKV admin user to perform REST calls. This slide shows how to update the OKV REST CLI.ini config file with the client wallet. The server is the IP of the OKV server. User is set to the user that will make the REST calls. Client_wallet is set to the subdirectory where the client wallet is stored. So we use the client wallet since every command that's ran through the OKV RESTful service utility requires a username and password. So if we set that the username and the client wallet information in the config, we will not be prompted every time we make a REST call via the OKV RESTful service utility. So this helps with automation. This what makes automation possible. For ExaDB Cloud to Customer Rack database endpoints, wallets need to be shared. For DataGuard OKV-enabled databases, the same wallet needs to be shared amongst all primary and standby endpoints. Also note that since the wallet is shared, the wallet creation is done only once. The first example shows how to create a wallet using the RESTful service utility. The options used: wallet for the wallet name, description for a brief description of the wallet, unique set to false to prevent OKV from generating a unique name for the wallet. Next command, creating endpoints. So first off, what are endpoints? Endpoints are systems where keys and credentials are used to access data. So endpoints can be Oracle databases, MySQL databases, application servers, Oracle ACFS, etc. In this example, the endpoint creation uses the following options: endpoint for the endpoint name, description for the description of the endpoint, the type for the type of endpoint, which in our example is Oracle DB, the platform where the endpoint resides, unique set to false to prevent creating a unique name for the endpoint. Wallet assignments. As mentioned before, for RAC ExaDB Cloud customers, we share the same wallet amongst endpoints. So when we assign the wallet to the endpoints, we want to make sure we are using the same wallet. And this is where we make sure that the same wallet is used amongst all endpoints via this command. In our example, you can see the wallet created in the first command being assigned to the endpoint that has been created in the second command. Endpoint software. So the benefit of using the provision command is that the command downloads and installs the endpoint client software within one command. The options used in this example, the intended endpoint to install the OKV client software for, the intended location where the endpoint client software bits, configs, libraries, etc. are stored, which is the OKV_home/OKV subdirectory. And the Oracle kernel actually looks for the OKV endpoint client software within this subdirectory, the OKV_home/OKV subdirectory. And auto login is set to false because we do not want to create an auto login wallet for the endpoint client software installs on ExaDB Cloud and Customer. As of today, the OKV endpoint client software password needs to be set to the TDE database password. Let me say that again. As of today, the OKV endpoint client software password needs to be set to the TDE database password. This ensures cloud tooling functionality on ExaDB Cloud and Customer. Although not pictured on the slide, after the provision command is successful, we run root.sh. Root.sh installs a shared library used for all database instant endpoints hosted on the nodes where the endpoints live. So root.sh may return different results depending on whether OKV was installed or not. And we'll go into more detail of that on the demo. Automation. One of the benefits of using REST is automation. Automation entails scripting the download of the RESTful service utility, scripting the OKV onboarding process, which is OKV_home creation, wallet and endpoint creation, wallet assignment to the endpoints, downloading and installing the endpoint client software. Automation takes all the steps explained in the previous slides and consolidate the commands into scripts. So in this slide is the lead script. The lead script is the script that creates the wallet. And as we mentioned before in previous slides, that the wallet is shared, so only one wallet creation needs to be done. So let's go into this script here. So the light purple highlight shows the download of the RESTful service utility via curl. The red highlight shows the building of the deployment script. So the deployment script will contain the OKV onboarding steps: wallet creation, OKV home creation, endpoint creation, wallet assignment, and downloading and installing the endpoint client software. The yellow highlight indicates the OKV_home creation, which will be in the deployment script. The green highlight shows the wallet creation, which will be in the deployment script. This is the wallet that will be shared amongst the endpoints in the RAC database or data guard setting, excuse me. The orange is the endpoint creation, which will be in the deployment script. The blue highlighted command assigns the default wallet into the endpoint, which will also be in the deployment script. And the lime green highlighted command is the download and install of the endpoint client software, which will also be in the deployment script. And please be aware that in this example, when the send command is there, we actually hard code the TDE password there. The secondary script has all the commands of the lead script except the wallet creation command. The secondary script or follower script execute on all endpoints that would share the wallet created from the lead script. So once all of that done, once the install is done, we verify the endpoint client software is installed by using OKV util, specifically OKV util list. The OKV util list verifies communication functionality with the OKV server. OKV util is used to change the OKV endpoint client password, upload and download wallets, and collect diagnostic information if necessary. Database changes. So we'll talk about OKV util being used to upload current TDE wallets to OKV, adding secrets for the external key store and auto login wallet, initialization parameter changes for wallet_root and TDE_configuration, and for 12.1 databases and 12.2, secretnet.aura changes and rack config changes, and the migration command to OKV. So in order to upload the current TDE wallets, we have to find said wallets. We can either query the database for the TDE wallet root location, or you can check the directory setting for the encryption wallet location entry in the secretnet.aura file. I recommend the query since the wallet root location can change and the secretnet.aura may not be updated to reflect this change. Once we determine the location of the TDE wallets, we copy the TDE wallets to the subdirectory and then upload the copies to the OKV server. The OKV util command listed on the slide uses -L for the location of the copied TDE wallets, -G for the wallet name we created, -T for the type of store. Now this can be SSH for SSH keys, Java key stores, etc. In our case, the type is wallet. Since we are sharing the wallet, the upload shall only be executed on one node. Once the wallet has been uploaded successfully, we verify the upload by running OKV util list. The OKV util list should return the same results on all endpoints that are sharing the same wallet. So this is every rack instance endpoint, every primary and standby rack instance should return the exact results. Adding secrets. What are secrets? Secrets are data that support internal Oracle database features that integrate external clients such as Oracle Golden Gate or Oracle Key Vault into the database. So the first secret creates an external key store that helps with database key management. The external key store removes the clear text password for key management. So for example, instead of entering the password to open up a key, the external key store allows the identified by external store clause. The second secret creates an auto login wallet for the wallets that were uploaded to OKV. So both commands need to be executed on all endpoints. Initialization parameter changes. So the wallet underscore root and the TDE underscore configuration initialization parameters need to be updated to migrate to OKV. The wallet underscore root equals OKV underscore home. The wallet root determines where the OKV endpoint client software, the external key store, and the auto login wallet are located. Also, the wallet root settings overrides the encryption wallet location entry in the secretnet.org. The TDE underscore configuration is set to OKV and file to accommodate the file to OKV migration. OKV is listed first to indicate OKV is the primary key management, file being the secondary. To configure OKV for the 12.1 databases and 12.2, we update the secretnet.org method to HSM, which is hardware security module, for the encryption wallet location entry. And the Oracle underscore base and Oracle underscore unique name need to be set for the rack environmental settings for the 12.1 databases. The migration is then complete by running a migrate command. Please be aware that the migrate actually rekeys the entire database. So this takes about a minute. So please be aware of that. So in the past, OKV-enabled databases were unable to take advantage of the cloud tooling functionality since the tooling was not OKV aware. And this is critical because the cloud tooling synchronizes metadata between the KVM guest and the control plane. It also provides multiple utilities to manage various maintenance tasks, some of which are not available via the UI. So we need to update the cloud registration files to ensure the cloud tooling is OKV aware. Please be aware, CREG files are important for cloud tooling functionality. So normally it's not recommended to update CREG files. However, updates are necessary for the OKV and tooling functionality. The following settings will be added: the TD underscore OKV underscore config and the OKV underscore wallet name. So the TD underscore OKV underscore config equals 1 indicates to the tooling that the database is OKV enabled. The OKV underscore wallet underscore name is more informative. You will see more information in backup reports when this option is set. The rest of the settings are either updated or need to be verified. The enable underscore wallet underscore root is enabled by default. The TD underscore wallet underscore root indicates the wallet underscore root for the TD wallets. The wallet underscore root indicates the initialization parameter setting for the wallet root. The TD underscore KS underscore LOC specifies the TDE key store location. The TDE underscore KS underscore ACFS equals no indicates that the TDE key store is not stored on the ACFS mount. Now listed is the MOS node published for the OKV migration using REST. We will follow this MOS node for the demo. So let me pause the recording right here and get the demo ready. Okay, a few things to be aware of. The demo is executed on a 2-node ExaDB Cloud Customer rack cluster. We follow the MOS node 28.28.575.1, which is mentioned in the presentation. And we use automation for the OKV onboarding process, which is done for the sake of time. And we use the automation scripts within the MOS node. Please be aware that although the MOS node says that, hey, this script is named OKV underscore lead and OKV underscore follow, they are the exact same scripts that you will see in the demo. That is actually a different name. I believe the lead is OKV underscore setup and the follower is like OKV underscore minor or something like that. So, so let's just get the demo going. Okay, first here we check the RDBMS versions. Make sure it's 19.6 and up, and it's 19.14 here. And now we're checking the DBAS and DBCS agent versions. And you see everything looks fine. It's 21.4 for the DBAS and 21.3.1.1 for the DBCS agent. Okay, let that. Okay, let me pause here. All right, so first and foremost, a few things. The source files. The source files are created by default if you create the databases via the UI or the tooling in ExaDB Cloud to Customer. So they just have the necessary environmental variables set for that particular database. And also here, as I mentioned before, the OKV setup equals the OKV underscore lead script in the MOS note, and the OKV underscore minor equals the follower script in the MOS node. These are the exact same scripts there. These automation scripts, as I mentioned before in previous slides, what this does is it actually builds, it actually creates the subdirectory for the OKV RESTful service utility. So it also downloads that the OKV RESTful service utility within that subdirectory. Then it builds the deployment script. The deployment script is where you have all the OKV onboarding processing, the creating of the OKV home, the creating of the wallet, the creating of the endpoint, the assignment of the wallet to the endpoints, and the downloading and installing of the OKV endpoint client software. All that's done within the deployment script. So it builds a deployment script after it's executed. Also, the OKV underscore lead is the one where we actually create the wallet in. The OKV minor in this example, or the OKV underscore follower, actually assumes that that wallet has been created. If the wallet hasn't been created, or if the wallet hasn't been created, then the command will actually error out. So you want to make sure that you're using the correct wallet. Please be aware of these. You can customize the script as much as to suit your environment. However, where the wallet was named is the wallet name that was used in this particular script were like database name and the actual cluster name. So I don't know, you may have some other unique tags that you want to use for your wallets, but you definitely want to make sure that the wallet is unique, because you definitely want to have other endpoints using wallets that are not intended to use. So, all right. And also these particular scripts you pass a database name to them. The reason being that was set up is to in case we have customers where they have like hundreds and hundreds of databases that they plan on migrating to OKV on the ExaDB Cloud to Customer environment. So what this does is if you have like a list of databases within a particular like trace file or what have you, you can run a for loop on that, but run the script within a for loop and pass, the database entries into the script, and it actually builds all the deployment scripts for those particular databases. So it makes the OKV migration process a lot easier that way. So let me continue. Hey, here you see the database name. Pause. Okay, so like as I mentioned before, the OKV REST is the subdirectory that will hold the OKV RESTful service utility. You will see that the curl command was executed and downloaded within the OKV REST subdirectory. Also, you get the message of building the OKV deployment script in the background, where we will see that deployment script later, where it has all the OKV onboarding process. And also we get a message saying, hey, we need to update the OKV wrapper script and the OKV REST CLI.ini config file. After this, then we will actually create the subdirectory for where we'll hold the client wallet. This actually could have been added to the automation script, but I don't know why. I just totally just forgot to add it in the script. So, but yeah, you can add that into your script and just go for there. So let's play. Okay. And that's the subdirectory for the client that will hold the client wallet. And you run the same on the other directory, on the other node. Okay, and it creates the client wallet here. So now that's done, we update the OKV wrapper script. All right. Let me set the environmental variables, the REST CLI underscore directory, and the Java to the current JDK home. The current JDK, yes. And yeah, we do it on the other node as well. REST subdirectory where the REST bits reside, yes. So we're doing this because we want to set up to use automation. That's why we're building the client wallet. The client wallet allows us to run the OKV RESTful service utility commands without being prompted for a username and password. We're just setting up our user and our login information within the config. So right now, in order to build the client wallet first, though, we have to be able to communicate with the OKV server. So we just, in the config, the OKV REST CLI.ini config file, we just put the OKV server IP in here in order to build the client wallet. Okay. And now we build the client wallet. Get that out the way. Okay. And build a client wallet there, and we'll just verify that the wallet was created. Just sanity for sanity's sake. And now we just add the client wallet information into OKV REST CLI.ini config file. So this allows for automation. Now we're setting up our user, a REST underscore build out, a generic REST user, and a client underscore wallet set to the subdirectory where the client wallet is located. Now we're ready for automation. Yes. So now that's done. Now we're ready for automation. So now we go to the deployment scripts. And we full screen this so we can see everything. Yeah, trace the OKV underscore home, trace the wallet, trace the endpoint, sets the default wallet to the endpoint, and download and install the software. We'll just run this. Yep. No prompt for username and password. And click the wallet with the endpoint. Wallet, download and install the software. Yes. Now we can run this on the next node. Run the deployment script. And we get the message saying, hey, wallet creation now run, because we're assuming that the wallet has been created by the lead script. Clear, and now we run root.sh. Okay, let me pause here. Okay, so when you get the message like this, creating directories, setting library file permissions and installation successful, that's how you know that OKV has yet to been installed on this environment. If OKV has been installed for like another endpoint, another database endpoint, you'll get a message like saying library already exists, and that's fine, right? However, there has been times where OKV has been installed on here. OKV endpoint client software has already been installed for other endpoint, but you're installing, like, say, for another database, but the endpoint client software has been updated with a new shared library. It will give you a prompt of like, hey, there's a more recent library that has been shared library that can be installed. Do you want to overwrite the current shared library? And you just type Y for yes and just go from there. Okay. And run root.sh on the other node. Good. Now we want to verify that the communication functionality to the OKV server is fine. So we use the OKV util list for that. And it also verifies that all endpoints are using the correct wallet, because the entries should be the same. Okay, the unique ID, we're just only concerned about the unique ID here. And the unique ID. All right, looks good. So we're good to go. Now we're ready to do some database changes. This is where we add secrets. Well, first we had to upload the wallet. Sorry, so we create encryption underscore wallet to find the current TDE wallets. And by default, on databases on ExaDB Cloud, a customer use an ACFS mount to share the wallet amongst the rack instances. So what we would do is copy those TDE wallets from the ACF mount locally, just for sanity's sake. Make sure we don't do any changes or anything to any wallets that are currently being used. Now, once we found those, copy them to /TDE, we upload those wallets to OKV server. Upload -T for the type of store, which is wallet, -L for the location, which is where the copy wallets reside, /TDE, -G for the wallet name. Make sure you get that correct. Make sure we're using the correct wallet. And -B for verbose, but that's not necessary. So here, when you say enter source wallet password, you can hit enter because auto login wallets are created for databases on ExaDB Cloud customer by default. So you can hit enter there. And enter the OKV Vault endpoint password is what we set to the TDE database password. And we set that during the downloading and installing the endpoint client software. So we do the OKV list, verify the unique IDs look the same on all endpoints, which also lets us know that we're using the correct wallets for each, or we're sharing the same wallet. With IDs, they look the same. We're looking good. Okay, so now more database changes. So we need to add secrets and need to do initialization parameter settings. Okay, external key store for key store management. Just to verify that it's created and it looks good. So we need to run it on the other node as well. Great. Now we need to add the secret, yes, for the auto login wallet for the wallets uploaded to OKV, and that's good. And now we need to update the wallet underscore root, change it from the ACFS mount to the local subdirectory, which is great. The TD underscore configuration, key store configuration equals OKV pipe file, OKV being the primary, file being the secondary. We need that for the file to OKV migration. And now we reboot to make sure everything is fine. If the database has trouble finding the wallet, you will find that issue on reboot of the database. So just a FYI. However, if you follow the Moss node to a T, you should be fine. You should be fine. So we stop cleanly and we start it up. And once this is done, we will run the migrate command. Actually migrate the file to OKV. Great. All right, everything looks good. Now, let's actually want to run a query I want to talk about real quick. Let me pause the demo. Pause. Okay, so this query is found in the Moss node as well. One thing I wanted to stress is the wallet order. Single meaning that this particular key has not been through the migration process as of yet, right? Once the migration process will migrate to OKV, once that is complete, the wallet order would change. It would show as like in our TDE underscore configuration settings, it would show that OKV is the primary and file is the secondary key management system. Okay. All right. And also, please be aware that even although you have migrated to the OKV migration, migrated to OKV successfully, any PDB created after that will show a wallet order of single, which makes sense, right? Because it hasn't gone through a migration process. And that's fine, right? Because we have OKV as the primary key management system at that time. And also there's a table that explains the different wallet orders in the Mons node here. And here's the migrate command. And this runs about a minute. It rekeys the entire database, so hence why it takes some time. Great. So everything looks good. Now this time we bounce the database. Make sure everything is clean. And once the database comes up, then we're going to run that same query. You'll see the wallet order has changed to OKV being primary and file being secondary. Okay, start the database. Okay. Let's go plus, run the query. Boom, primary, secondary. Looks good. Now we do the ExaDB cloud customer changes, the CREG changes, the cloud registration file changes. As I mentioned in the presentation, we normally do not recommend making changes to these files because they are essential to cloud tooling functionality. However, we need to add these changes in order to make the database or the tooling aware, OKV aware, I should say, make the tooling OKV aware. See here, the TD wallet, need to change that. We just comment those out. Change it to OKV_home. Wallet root, we need to change that to the wallet root setting in the database, which is OKV_home. Key store location for the auto login wallet. TDE. SFS equals no. That's it. We go to the other node and do the same. And after we make these changes, since this is manual entry and it can be susceptible to human error, so we want to make sure that once you make all the changes, you do like a cat and grep for like wallet or TDE to make sure the entries are proper. Home, root, key store location. Yes. Set to no. And I believe I forgot the wallet root, if I remember correctly. Yep, forgot the water loop. Need to go back in and change that. So that's why we do these sanity checks. So once all the changes are done, everything looks good, you are good to go. Cloud tooling is OKV aware. So you can create PDBs via the tooling. You can do your backups via backup API. You can use the tooling functionality while the database is enabled with OKV. So, and you're ready to go. I hope that this presentation helped. I hope this demo helped. There will also be a demo with DataGuard. We're not going to have a long presentation. I think the DataGuard presentation will probably just be like 1 or 2 slides, if that. But it's more focused on demoing the OKV migration on the ExaDB Cloud to Customer environment with DataGuard in place. I hope you enjoyed that. I hope you enjoyed this presentation, excuse me. And thank you for your time.